the Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month. I'm your host, Dave McDonald, and this is May 2023. And what a great month to look up at the night sky. Every month has great objects to look at, and we feature, would you like to see Halley's Comet? It's possible. I'll tell you a little bit more about that in a little bit. Looking ahead just quickly to June, a lot of people don't realize that your astrological zodiacal signs are not what you think they are. You want to find out what they are? Well, come to the McAuliffe Shepherd Discovery Center for our Superstellar Friday, June 2nd. So that's Friday night, June 2nd at the McAuliffe Shepherd Discovery Center in Concord, New Hampshire. And we'll get you all straightened out about how the zodiac works and how the signs have changed and how you're not what you think you are, and you may even be the sign of a constellation you've never heard of. So come on down to the McAuliffe Shepherd Discovery Center. That's Friday night, 7 o'clock. Come before 7 on June 2nd. Well, behind me you can see an image, and it's really kind of exciting. And it's a spacecraft. I'm just going to lean over here just for a second. And it's a spacecraft. It's the European Space Agency's, there it is, European Space Agency's Express mission to Venus. And Venus we're going to be chatting a little bit about, or maybe a lot about, this program, because Venus is so prominent in the night sky. When you look westward after sunset, you cannot miss Venus. And if you are interested in a little bit of a project, try to find Venus before the sun sets, but keep your eyes away from the sun, because Venus is not that close to the sun. There's no need to look near the sun. See if you can find Venus at noontime. It's possible. I've brought my astronomy class outside, and we can spot Venus in broad daylight. So I'll leave that to you to do a little research on the internet as far as where to look, but it's going to be towards the east of the sun, so 30, almost 30 degrees or so, or 2 fist widths or so away from the sun to be looking for Venus in the daytime. It's doable. So Venus, you can see an image right here. Why is Venus so bright? Well, there are a few reasons. One is it is close to the sun. It's the second planet from the sun. Of course, Mercury is first, and then Venus is second, closest to the sun. But you can see there in the picture that it's shrouded in clouds. You cannot see the surface of Venus through a telescope or even flying or orbiting around Venus with regular cameras. You need to get through the clouds or land on Venus. And I'm going to show you in just a little bit about a lander that actually landed on Venus and took some good images before it melted. It's so hot. So Venus has what we call a high albedo. Albedo. And albedo is a measure of the reflectivity of light, typically from the sun, the reflectivity of the light bouncing off an object, in this case Venus, back to Earth. So high albedo, close proximity to the sun, close proximity to Earth. Put those factors together, and we have a bright object in the sky glowing at a magnitude negative 4.1 towards the beginning of the month, and increasing to a negative 4.5 magnitude. And you may remember that the smaller the number, or the more negative the number, the brighter the object. So the only thing to outshine Venus in the night sky would be if the moon was out in the night sky, which, of course, from time to time it is. So Venus right there. Let's take a peek now at a comparison of Venus and Earth. Size-wise, you can see Venus is very similar. At one time, it was considered to be a sister planet, but now we know it's, we don't want Venus to be our sister anymore. So what you're seeing here is some radar imaging through the clouds of some surface features of Venus using some techniques to look through the clouds, basically. But you can see Venus is a little bit smaller than Earth, but roughly about the same size. And this was known for quite some time, and that's why it was considered to be our sister planet until we learned a little more about the fact that, you know what, it's the hottest planet in our solar system. You may say, well, isn't Mercury closer? Yeah, Mercury's about twice as close as Venus, or you could say Venus is twice as far away from the sun as Mercury, but Venus has this cloud structure, and this cloud structure of Venus is trapping the heat. So if you can consider, like your car, you go shopping at Walmart, right? So you're at Walmart shopping, it's maybe 75 degrees outside, nice t-shirt, sweatshirt weather, and you go in, you come out 2 hours later, open the car door, you know, we're in May, and it's like, whew, 90-degree air comes out. How did that happen? Well, the radiant energy from the sun goes through the glass in your car, increases the kinetic energy of the molecules, the air molecules inside the car, that those molecules don't get to escape, but because of their higher kinetic energy, their temperature goes up, and you have a hot air in your car. Same thing happens with Venus. The radiant energy comes through the clouds, gets the molecules in the atmosphere, which is not like ours, no oxygen down there, but gets the molecules active, increases their kinetic energy, the temperature rises and rises and rises and can't escape out through the clouds. So we have what's called a runaway greenhouse effect, and the temperature approaches 950 degrees Fahrenheit. So pretty amazing. So back to size comparisons, you can take a peek here, and you see that you have Venus, again, a little bit smaller than Earth. And then we have the moon, and we have Mars. You can see here, right? I'm circling the moon with my red laser pointer, and then Mars, because we're going to talk a little bit about Mars tonight as well. So that's a good idea of the size comparisons of these 4 objects. So I mentioned to you the Venera mission, and so here in front of you is the Venera 13 mission, and it took some very cool pictures. Notice this is back in the time of the Soviet Union, and they sent this Venera mission, a number of Venera missions, and you can look up and Google the different missions and what they took, but Venera 13 did an amazing job. So here you can see in this image here, this is shortly after landing, and the camera is a pretty wide view camera, but we're kind of looking at the landing feet and the landing foundation, if you will, of the spacecraft on the surface of Venus. And those pointers mean something in terms of color and direction and such. And then if we move on to the next photo, you can see what's in the foreground there, but now we see more of what's in front of it, and that's a pretty good picture of exactly what's on the surface of Venus. And you can see the rock formation, some hills in the distance and such. And this is a close-up here that you can see of the rock field that's there, and you can see the hill in the background. So it's a rocky place. It's a rocky planet. It's a terrestrial planet. One of the rocky planets, terrestrial. We got Mercury, Venus, Earth, and Mars are in that category. And then here is another wide image of all of that we've seen. It's the wide field camera, and you can see the place where basically the camera is located on the spacecraft. So we have some pictures, and again, I think 15 to 20 minutes is about the length of time that the cameras were operational, and then it succumbed to the temperature, 950 degrees, and also the pressure. So when you look at Venus, realize that the pressure is about 100 times more than what we have here on Earth. So we're talking 14.7 pounds per square inch here on Earth. Well, how about 1,470 pounds per square inch if you're on Venus? Okay, so what I'd like to do now is we had a great time at the McCall Shepherd Discovery Center on April 8th, and that was our pre-eclipse anniversary show, because April 8th, 2024 will be the eclipse. So here's just a few highlights of the April 8th celebration at the McCall Shepherd Discovery Center. So it was a really fun time. You saw all the telescopes. It was a great day, clear day, great views of the sun with our special solar telescopes offered by the New Hampshire Astronomical Society and in our own observatory at the McCall Shepherd Discovery Center. And we had a special program that you saw the intro of Rick Ames and myself. And we invited some students from the elementary school in Holderness, and Emily is their teacher, and they are junior solar eclipse ambassadors, and they showed us how eclipses work and how we can keep ourselves safe. So enjoy this little video clip of the students at Holderness Elementary School explaining to us how to enjoy the eclipse, how it works, and how to be safe.
Without further ado, I'm going to introduce Emily as their teacher advisor, faculty advisor, and they can come on up and lead you in some of the training they've done.
So this is Sophia, and she started being an ambassador in 6th grade, because we have to have them all the way till 2014 in the spring. So she was a 6th grader, 7th grader. This is Hannah, this is Jade, this is Oliver, and this is Tyler. And they are Aurora. She's hiding. And they are our ambassadors, and I will let Sophia introduce them.
We are a group of 6th and 7th grade junior ambassadors from Holderness Central School in Holderness, New Hampshire. And we're here to teach you about solar eclipses and how to look at them safely. There are 2 solar eclipses, one in October of this year and one in April of next year. And there are 6 students, just like Mrs. Kelly said, and we are going to teach the K through 4 at our school about this. We are going to go to library, book groups, PTAs, and we are also going to teach other middle school students in the SAU so they can become junior ambassadors themselves. And so here's Aurora with the basics of solar eclipse. Yes.
Our group will be using this flip chart to teach about solar eclipses. An eclipse is when one object in space comes between the sun and another object in space. A solar eclipse is when the moon comes between the sun and Earth, casting a shadow on the Earth. The moon's penumbra is its wider shadow. Areas in this experience a partial solar eclipse. The moon's umbra is the darkest part of its shadow. Areas in this small portion of the Earth experience a total solar eclipse.
Hi, I'm Oliver, and Tyler and I will be showing you about solar eclipses with this graph. This is the Earth, Moon, and the Sun. And now I'll give the microphone to Tyler for more.
When the moon blocks the sun's rays and projects it onto the Earth, it creates a solar eclipse. As the Earth rotates, the moon's shadow moves moves across the Earth, making a solar eclipse.
This is one of the models we're going to be using to teach today. What you're going to need is a circle cutout that will represent the sun. Your body's going to represent the Earth, and your thumb will represent the moon. Jade will be showing us today. So she's going to close one eye and back up about 10 to 15 feet. And she's going to use her thumb to cover the sun like a solar eclipse and then exit from the sun just like a solar eclipse. And this is something that you can do at home or in school.
I'm Hannah. I'm going to teach you how to safely wear solar eclipse glasses. So the junior ambassadors will demonstrate how to put them on correctly. So the first step is you look down. This is a very important step because the sun could damage your eyes or even blind you if you look directly at it. Then you can put the solar eclipse glasses on, and finally you can look up. Now they can observe the solar eclipse safely. So the sun looks like during totality, you can see the corona around it, like on the shirt and on some of the diagrams, and you can see it. It's normally black around it, but you can see the corona and the circle inside, which is the moon. And yeah.
Okay, hey, wasn't that neat? Those kids, and that was their first ever presentation to a group of people present in an audience, and I think they did a great job. And I'm sure they'll watch the video and work out any bugs and continue to improve their program. And hopefully in next month's show, we'll introduce to you a high school solar system ambassador. So let's take a moment to readjust the set and show you some things that are going on in the night sky with planets and constellations. And I'm going to tell you a little bit about how to see Halley's Comet. Well, I showed you this diagram a little bit earlier, but I want to talk a little more specifically about what we're looking at here. Again, this is the month of May, and the beginning or the tail of these arrows is where the planet is at the beginning of the month, and the end of the tip of the arrow is where it is at the end of the month. And I want to give a shout out to Astronomy Magazine and thank them for this great illustration of the position of the inner planets plus Jupiter. So this is where Earth is and how Earth moves. And so let's just talk a little bit about the perspective from Earth. So at the beginning of the month, Earth is here, and we're looking at the reflection of the sun off of Venus to Earth, and so it makes it very, very bright, and we can see Venus has phases. So if you have a telescope, a small telescope even, and look at it and sharpen the focus of Venus, again, you're not going to see any surface features because of the clouds, but you will see the phase will be changing. And as time moves on, it's going to move to about 50% lit up. And as I mentioned, it's moving from a negative 4.1 to a negative 4.5 magnitude. So as it gets closer to Earth, it's also going to be appearing to be brighter. Now, Mercury, you may remember last month, was featured in the night sky, but now you can see there was a point of what we call conjunction, where at the beginning, the very beginning of the month, Earth to where Mercury was lined right up with the sun. But now as May moves on, Mercury is a lot faster going around than Earth is. So Mercury is coming around, and on May 28th, 29th is a position that we call greatest western elongation. And that position of what greatest western elongation is going to be the sweet spot to be trying to find Mercury again, only this time in the morning sky. And speaking of the morning sky, you can see Jupiter here, and Jupiter is now going to be a morning sky object. It passed a position we know as superior conjunction with the sun as it comes around. So Jupiter will be becoming more and more visible in the morning sky. Now, Mars, we wanted to talk about Mars a little bit, and so from planet Earth, again, we have the planet Mars, which you can see is a shorter arrow because it's further away from the sun. It moves more slowly. But it's making some progress around. And as Earth moves around towards the end of the month, Mars moves around, and we're increasing the distance. And it's going to be about 2 AUs, about 2 astronomical units before the month is over. And because we're moving further away from Mars, because Earth is going faster, Mars is going slower, the distance between us is increasing, Mars is shrinking in size that we look at to about 5 seconds of arc, which is plenty big to see a disk, but very difficult to see any surface features. But you'll see the red planet, and when I look at the red planet, I like to imagine the fact that we have rovers up there. Not only do we have Curiosity and Perseverance, we have a helicopter, Ingenuity, that's up there on Mars flying around over 50 flights. They were hoping to get 5 flights, and we're doing some serious science with it at 50 flights. So you can look that up online too, Ingenuity on Mars. The helicopter on Mars. Who would have guessed that would be happening? So Mars, I'm going to show you in just a little bit where you can find it in the night sky. And as I mentioned, Mars has a small disk of 5 seconds of arc, and Venus is huge, 23 seconds of arc as we get closer. So we're talking at least 4 times larger than the apparent size of Mars. So it's pretty neat. And the planet Mars is going to be moving into the constellation of Cancer mid-month, and it's going to be approaching, and I'm going to show you in just a little bit, the Precipice, or the Beehive cluster, or M44, at the very end of the month and the first couple of days of June. That's going to be really nice to be able to take a picture of. So you're going to want to check that out. Let's go to the next slide. So that's a little bit of how things are oriented. Now we're at May 15th. We're at the middle of the month, and the middle of the month around 9 o'clock, you can see Venus very, very blazing, very, very bright. And these 2 stars that are above Venus, so to speak, those are the eyes of the twins, Castor and Pollux. Now, if you remember about the star Capella, which is over here, I'm stepped off the screen, so you can see Capella is a magnitude 0 star, yellow in color, and Castor begins with a C, Capella begins with a C. That's how I remember which one's which. So Mars is like lined up with Pollux and Castor mid-month, and Venus still blazing, very, very bright. Again, we're about 9 o'clock on May 15th. Procyon is the little dog star, Canis Minor. And then up above, I'm going to show you a little more detail later, but you can see the backwards question mark here of Leo, the lion. That's the lion's head, and his hind haunches and tail is just off the top of your screen. We'll talk a little bit more about that. Okay, so this is May 15th. So we're going to jump to May 30th, and you see here now things have changed a little bit. So this is Castor and Pollux, the eyes of the twins once again, but now you can see instead of Castor and Pollux lining up with Mars, they're lining up with very bright Venus, and Mars has moved up a little bit. And this is the twins, right? Castor and Pollux, those are the twins, Gemini. And then we have that backwards question mark, or what sometimes referred to as the sickle of Leo here. The brightest star is called Regulus, representing the heart of the lion. And then that triangle is your hind haunches, and Denobula represents the tail of the lion. And so you can see that Mars is now moving in between Gemini and Leo. And what constellation is in between Gemini and Leo? Cancer. Cancer the crab. So let's go to the next slide. And the next slide, Cancer is kind of dim, but it's kind of a upside down Y, I think you can see that concept right here, this upside down Y. Fainter stars, but you can make out the upside down Y. That's Cancer the crab. And now you can see Leo the lion much more definitively. And then the twins are getting ready to set. We're 9:30 now because you can see there's still a little lightness in the sky. We're at 9:30 now. Venus is shining ever so bright. The way it's depicted here, it almost looks like a full moon, but it's the planet Venus because it's so bright. And Mars is now in the constellation of Cancer, approaching the middle of that Y is that fuzzy spot, M44, the Precipice, or what's called the Beehive Cluster, and it's going to be a great picture. So let me show you a picture of the Beehive Cluster through telescope. Isn't this amazing? And maybe you can see, and maybe you would agree, it looks like a bunch of busy bees. So many stars there, a lot of bright stars, but that's the Precipice, and that Mars is going to be moving through this the end of the month and the beginning of June. Very cool. Next, I want to go back to May 15th, so we're at the middle of the month, and just to point out a couple other stars and constellations that you can find. So we're facing southeast right now, southeast. So basically in overhead position, you can see the Big Dipper, right? You see the Big Dipper, the dipper part, and here's the handle. And if you remember, you can take the handle of the Big Dipper and see how it makes an arc. Well, it can arc to a star called Arcturus. Arc to Arcturus. It's a magnitude 0 star, just as bright as Capella, only instead of being yellow, it's decidedly reddish. And if you look carefully at the stars coming up to the upper left of Arcturus, I think it looks like an ice cream cone. It's technically the constellation of Boötes, the herdsman, but I see an ice cream cone, probably because I like ice cream. So if you take that curve or the arc of the Big Dipper and you arc to Arcturus and then go down towards the horizon, you're going to spike down. You can see it way down here. I'm bending over to Spica. Spica is the brightest star. It's a magnitude 1 star. So Arcturus, being a magnitude 0, is 2.5 times brighter than Spica. And Spica is a bluish-white star. So you can definitely tell the color difference as well. And as the night goes on, it gets further away from the horizon, easier to see and easier to tell. So there's a couple of constellations and stars that you can see throughout the month. I just chose May 15th because it's in the middle of the month, but these constellations will be up and available for your enjoyment all month. Now, this next slide is the reminder of Halley's Comet. So one thing that you may not be aware of is that meteors, when you see meteors in a meteor shower, what you're seeing is the debris left by a comet. So we have a meteor shower called the Eta Aquarids, and the Eta Aquarids is happening May 6th. That's the high point. A week in front, a week in back. You can enjoy going out and looking, but this representing, it is a comet, and this comet goes around the sun and it leaves debris behind. And when you look at the Eta Aquarid meteor shower, you're looking at the debris left behind by the comet Halley. Isn't that cool? So that's May 6th. The problem with it is typically you get about 50 meteors an hour when the radiant point of Aquarius is high in the sky, but we have a full moon situation on May 5th. So only the brighter or the brightest meteors you will see, but it's definitely worth taking a peek after midnight. Somewhere between midnight, 3 o'clock in the morning will be your best views May 6th, but a few days ahead, a few days after May 6th, whenever it's clear, whenever it's convenient, enjoy going out to see the Eta Aquarids. Don't forget to meet me in person at the McCall Shepherd Discovery Center Friday night, June 2nd. I'll be talking about unveiling the mysteries of the zodiac. And I hope that you enjoyed the students from Holderness Elementary School. It was a great time on April 8th that we had. Looking forward to the New Hampshire total solar eclipse way up north in Coos County next year, April 8th, 2024. So I hope you enjoyed the show. I'm your host, Dave McDonald. You see my email. Feel free to write me any questions or anything that you'd like me to talk about in the future. I want to be very interactive with my audience, no matter where you are in the country. I care about you and your enjoyment of the night sky. So everybody, for my old friend, Jack Horkheimer, keep looking up.